A function f from R to R defined by f of x is equal to x minus m upon x minus n, where m is not equals to n. We need to check whether this function is one-to-one or onto. We know that condition for one-to-one, f of x is equal to f of y implies x is equal to y. This is the condition for one-to-one. So let us consider f of x, that is x minus m upon x minus n, is equal to f of y, that is y minus m upon y minus n. The cross multiplication x minus m into y minus n is equal to y minus m into x minus n. So xy minus my minus nx plus mn is equal to xy minus mx minus ny plus mn. On simplifying, mn gets cancelled on the same both the sides, and here we can write xy, and xy also gets cancelled here. So we can write here mx minus nx, and then ny minus my is equal to 0, or x taken common here m minus n, and here minus y taken common, so we can write m minus n again is equal to 0. So m minus n of x minus y is equal to 0, so which implies x minus y is equal to 0, that is x is equal to y. So for f of x is equal to f of y, we are getting x is equal to y, and hence we can conclude that f is one-to-one. Now to check for onto, let y is equal to x minus m upon x minus n, and onto definition says that for every y belongs to B, there exists at least one x belongs to A such that f of x is equal to y. So this is the definition for onto. So let f of x is equal to y. So on simplifying, y times of x minus n is equal to x minus m, or xy minus nx is equal to x minus m, or we can also write x plus nx is equal to we can write here x minus x plus nx minus ny is equal to m, that is x taken common. So here we can write x times of 1 plus n let's take the x terms together, x plus nx minus xy is equal to m, or we can take common 1 plus n minus y is equal to m. So we can write x is equal to m upon 1 plus n minus y. Sorry, here this is ny. So xy minus ny is equal to x minus m, or we can write x minus xy is equal to m minus ny, or we can take x common, 1 minus y is equal to m minus ny. So x is equal to m minus ny upon 1 minus y. So clearly we can say that here for y is equal to 1, x is not defined. means this x is a real number. Since it is given x is a real number, so for y is equal to 1 and codomain is also real numbers. So for y is equal to 1, we can say x is not defined. And hence there is at least one value of in the real numbers 1 for which the function is not defined, for which there is no value of x such that the function is defined, and hence we can conclude that this is not onto. So f is not onto. So when f is not onto, we can call it as an into function. So the function f is 1 to 1 and into. 1 to 1 and into function is option B.